Good morning, students. Welcome back to science class on the chapter work and energy. Uh, yes, here some students wish you happy Teachers Day. Then, so thank you for that one. Okay. Yes, come to the subject. In the previous class, we had discussed law of conservation of energy and rate of doing work. Okay, so energy can either be created nor be destroyed, but we can transform one form to another form. So before conversion and after conversion, the energy is constant, means energy remains same. So this is the law of conservation of energy. Also we had discussed it, right? So for example, electric energy, we can convert that electric energy into light energy, heat energy, sound energy, then kinetic energy, etc. Okay, so using hydro energy, using water, we can generate electricity, right? So that's why here we can convert hydro energy into electrical energy, and in the nuclear power plants, there will convert thermal power into electrical energy. So these are the examples for kinetic. These are the examples for energy conversions. Okay, so later we have discussed a rate of doing work. Okay, so for example, if an object you have just imagine you have one object. So in a given time, how much work it will do. So that gives the rate of doing work. So for that, we have formula, that is the power is equals to work done divided by time. Okay, the unit of power is joules per second. Okay, in the honor of scientist, so we use watt is the SI unit for power. Okay, for example, also we have studied the meaning of 1 watt. What is the meaning of 1 watt? 1 watt means if an object it will do 1 joule of work in 1 second, so then we can say that work the power of that object is 1 watt. Okay, so this watt is very small. Okay, so sometimes we have to use bigger units. At that time we use kilowatt, which means kilowatt is equal, for example, 1 kilowatt is equals to 1000 watts. Okay, yes. Next move to commercial unit of energy. Okay, commercial unit of energy. See, nowadays technology is very advanced. Okay, for example, just imagine you are doing one work. Okay, to complete that one, say you will take 4 hours or 3 hours to complete that work. Okay, but even that same work, the same work that done by the machines. Okay, those machines, they will do that same work within a fraction of second. Okay, why? Because those machines, they will consume huge amount of energy. Okay, at that time we use watt hour. At that time we use watt hour. Okay, for example, say 1 watt hour. 1 watt hour, we have one device. Unit of that device is 1 watt hour, which means if an object consumes energy, if it consumes an object energy for 1 hour. Okay, one object is doing one work. Okay, for doing one work, and it consumes energy, or the power of that object is say 1 watt. If that object do that work for 1 hour, if it consumes 1 watt of energy for continuous 1 hour, so then we can say that so here we can use watt hour. Okay, 1 watt hour. Even this is also very small. Okay, this is also very small. At that time we use 1 kilowatt hour. We use kilowatt hour. Okay, kilowatt hour. So now we'll discuss the meaning. See what is the meaning of 1 kilowatt hour? So 1 kilowatt hour means 1000 watt hour. Means if an object consumes, okay, 1000 of energy, 1000 watts of energy for continuous 1 hour, so then we can say that that is 1 kilowatt hour. Okay, so clear, right? So first, 1 watt hour. 1 watt hour means if you have one engine, okay, if it consumes an 1 watt of energy for continuous 1 hour, so then we can say, then we use 1 watt hour. Then the meaning of 1 kilowatt hour, if that machine consumes thousand watts of energy for 1 hour. So for every second that that engine is consuming energy, that is 1000 watts. If it consumes thousand watts for 1 hour, so then we can say that 1 kilowatt hour. Okay, so here now 1000 into, we can write 1 kilowatt hour is equals to into 3600. So convert that hour into seconds. Clear? That is 3600. Okay, so then we can write 36. Okay, next 3.6 into 10 raised to the power 6 joules. We can write 1 kilowatt hour is equals to 3.6 into 10 raised to the power 6 joules. Okay, because we measure energy in joules, right? So it's separating 1 kilowatt hour. Okay, so what is the meaning of 1 kilowatt hour? If an object consumes 1000 watts of energy for continuous 1 hour, okay, so then we can use 1 kilowatt hour. Okay, so 1 kilowatt hour, this is the commercial unit of energy. Commercial unit of energy. Why we are using this unit? Because machines, they will do lot of work, they will consume energy at the rate of 1000 10,000 like that. Okay, so that's why we use, because here we can't use 1 watt 2 watt, because if it is 1000 10,000 watt 1 lakh watt, and we have to write like this. Okay, because it will take time, it take more space, right? So that's why in short form we use this one. This work and energy chapter is also completed. So today now we will discuss some problems. Yes, so one more thing I have forgot to discuss. See, this is a ground. Okay, so here you lift an object, say from ground to here. So now we can say that the distance here h. Okay, so at this position it possesses potential energy. Now see, now same object I will lift, like say here I have lifted just like in a straight, like in a straight line like this. I have lifted this object, but here I have one more object. I lift in this way like this. First I will take that. Now first I lift the object here and I will take to this side, and once again I will raise it, and once again I will take this side and raise like this. Here also actually see, this is the path of this object, but here we won't take this height. Okay, because to calculate potential energy we know the formula, that is m into g into h. Here you have to take height, right? Okay, so here we can't take this height like this. Okay, you can see, you can lift this object by taking here or here or here like this, but ultimately, so this is the final position, right? So now what is the distance between from this position to ground or surface? So then we'll consider only that as the height. Okay, so here we won't take this path. Okay, we take straight path. Okay, you can lift this object by taking this side or that side, but ultimately we'll take the straight distance between the position of the object and ground. Okay, yes. Okay, still some students are wishing happy Teachers Day. Yes, so stop it now. Okay. Okay. Yes, so see here. Two girls, each of weight 400 Newton. Each of weight 400 Newton. Climb up a rope through a height of 8 meter. We name one of the girls A and other B. Girl A takes 20 seconds while B 50 seconds to accomplish this task. What is the power expended by each girl? Okay? Yes, do it. Yes, so tell me the answer, quick. Yes, A is 160 watt. Okay, good. Jyoti Young A is 60 watt. Very 60, 64 watt. Correct. See here. Here they have given weight. Okay. So here weight is equals to. We will discuss what is weight in the chapter gravitation in gravitation chapter. Okay. So here weight is nothing. It is also a force. Okay. Weight means it is a force between your body and earth. Okay. See here, two girls each of weight 400 climb up a rope through a height of 8 meters. They will climb up, right? Which means they will do work. Okay, they will do work. Means at the height, for example, this is a ground. They will climb up a rope. Okay, see here. So at this position, they will climb up. Say distance from here to here 80 meters. So now both the girls they will possess what kinetic potential energy, right? Okay, that is m into g into h. Okay, that is potential energy. Now we are how to calculate potential energy. See here they have given what that is a weight. I have told, right, weight is nothing but it is also a force. Okay, it is also a force. To calculate force we know this formula, right? F is equals to m into a. Okay, so here that see because both the girls they climbed up rope through height of 8 meter. Okay, so that's why here we use F is equals to m into g. Okay, here they have given weight. I told weight is what, 400, right? So that's why m into g is equal to 400. Okay, we'll discuss in the gravitation chapter. Okay, so here weight means what? Weight is also, it is a force. Okay, the force between your body and earth. So now mg is 400. Then your height is there, your right height, that is h. So potential energy is equals to m into g into h. That is 400 into 8. So what is the answer? 3200 joules. You know, in the beginning of this chapter we had studied, right? We will express energy in terms of work done. So work done is nothing but it is energy. Okay, so what you will do work, that work is very useful as work done. So that's why this potential energy is equal to work done. Okay, actually here we need power. To calculate power, we know the formula, that is work done divided by time taken. Okay, yes, first we will write. We know the formula, that is P is equals to work done divided by time. Okay, so they have given height is 8 meter and force. Okay, F is equals to m into g, that is 400. Clear? Then first calculate potential energy. Potential energy is equals to m into g into h, that is 400 into 8 is equals to 3200 joules. So this work done is equals to potential energy, right? So now substitute here. So 3200 divided by, what is the time taken? See, girl A takes 20 seconds. I will write TA, means girl A. The time taken by girl A, that is 20 seconds. Okay, I will write here 20. Cancel. 2 ones are 160 watt. So power of that girl is 160. Next, girl B. See, both will weigh 400 Newton, right? So that's why the potential energy of that girl B is also 400. But what is the time taken? Time taken is different. That is TB. Time taken is 50 seconds. Okay. First TA, for this one TA. Next TB. 50, 0, cancel, and this is answer 5 answer 564. 64 watt. Okay, the power of girl A is 160 watt and power of girl B is 64 watt. So clearly we can say that girl A has more power than girl B. Why? Because see, the girl has climbed the same height, right, in 20 seconds, but girl B she takes 50 seconds. So that's why we can say that girl A has more power. Okay, yes, next. Next one. Yes, see here, a boy of mass 50 kg runs up a staircase of 45 steps in 9 seconds. If the height of each step is 15 centimeter, find his power. Take g equals to 10 meter per second square. Here also we need power. We know the formula, that is power is equals to work done divided by time. Okay. Yes, first find out work done. Then they have given time, right? In 9 seconds. Okay. But here we don't know work done. How to calculate work done? Just think and do it. I'll give 2 minutes time. So already here some students answered. No, right? These answers, those answers are for previous one. Okay. Yes, do it fast. His answer is a 375 watt. Okay. Yes, correct. Yes, see here. Here they have given mass. M is equals to 50 kg. M into mass 50 kg. Plus the distance of 45 steps in 9 seconds. So here the 45 steps. 45 steps means into one, the distance of height of one step is 15. So 15 into 45. 15 into 45, that is see, just first multiply 15 into 45. Okay, then convert it into meter. So 15 into 45 is equal to 675. Okay, then convert it into a meter, that is 6.75. So 15 into 45 is equals to 675. If you come 675 centimeter, so convert it to meter, that is that is 6.75 meter. Okay. Next time, that is t is equals to 9 seconds. See that boy runs up a staircase, right? So, for example, say this is round. These are the staircase. So he'll climb up here. Okay. So we can clearly say that that boy possesses potential energy. First calculate. So potential energy equal to m into g into h. So what is the mass of that boy? That is 50. G value 10 and height 6.75. So 50 into multiply here, it is 67.5. So what is the answer? 60 into 50 into 67.5. Okay. 15 to 67.5, that is 3375 joules. Yes, correct. Now substitute here. So now this potential energy is equals to work done, right? So right here 3375 divided by 9. 3375 divided by 9. So here you will get 375 watt. So power of that boy is 375 watt. Okay. Yes, correct. Some students answered. Electric bulb of 60 watt is used for 6 hours per day. Calculate units of energy consumed in one day by the bulb. Yes, do it this one. So an electric bulb of 60 watt is used for 6 hours per day. 6 hours per day. Calculate the units of energy consumed in one day by the bulb. Yes, find the answer for this question. So here they have used for 6 hours, right? So that's why, because commercial unit we use kilowatt hour, right? Kilowatt hour. So convert that 60 watt into kilowatt hour. Okay. So first power of the bulb, that is P is equals to 60 watt. So convert into kilowatt hour. How to convert? That is divided by 1000. So we can write this as P is equals to 0.06 kilowatt. Okay, we can write that 60 as. Next, what is the time taken? That is T is equals to 6 hours. Okay, so they have asked energy consumed. So energy consumed. Energy means what? See, we know this formula. Power is equals to work done divided by time. So work done is what? What is work done? Work done is nothing but it is the power consumed, right? So that's why we can write energy consumed. Energy consumed. Power equal to energy consumed divided by time taken. Okay. So now we can write this formula like this. Energy, because energy is equals to work done, right? So energy is equals to power into time. So what is power? 0.06 into 6. 0.06 into 6. That is 0.36 kilowatt hour. 0.36 kilowatt hour. Okay, or we can write 0.36 units also. Okay, yes sir. Next one. certain force acting on a 20 kg mass changes its velocity its velocity from 5 meter per second to 2 meter per second. 2 meter per second. Calculate the work done calculate the work done by the force. Certain force acting on a 20 kg mass changes its velocity from 5 meter per second to 2 meter per second. Calculate the work done by the force. So we will write work done. So change in kinetic energy is also known as work. We can calculate change in velocity is equal to work done. Because here work is done to change its velocity from 5 meter per second to 2 meter per second. So what is that work done? To 10 joule. How it is possible? You are copying down from internet or what? Yes, correct answer. Okay. See first mass of that object, that is 20 kg. Initial velocity u is equals to 5 meter per second. Final velocity v is equals to 2 meter per second. So calculate the work done. Okay. So first calculate initial velocity and initial kinetic energy and final kinetic energy. First one, kinetic energy. Okay. And write initial kinetic energy. U is finite, that is half m u square. Okay. So 1 by 2 into, see what done, we can write it in a short form. Okay. So no need to do separate. So work done W is equal to final kinetic energy minus initial kinetic energy. So what is the formula? That is half mv square minus half mu square. Okay. So take outside half m common, right? So we can write work done is equals to half m into v square minus u square. Okay. Now substitute the values. W is equals to half into m. M is that is 20 into, what is v value? V value is 2. 2 square minus 5 square. 2 ones are 2 tens, and that is 10 into 2 is 4 minus 25. So 10 into, what is the answer? That is minus 21. So finally work done equal to minus 210 joules. Okay, here we got minus. What it indicates? Yes, tell me the answer. So here we got minus 210, right? Now what it indicates, that minus sign? Quick. What it indicates, that minus sign? Help me fast. Yes, it is in the opposite direction. What? See here, the car is moving. Sorry, which one? Certain force acting on a 20 kg mass changes its velocity from. Yes, one object is moving with 5 meter per second. Here the force is applied, means work is done. So here its velocity changes from 5 to 2. So which means here that applied force is in the opposite direction. Yes, very good, Channu Patil, right? The force acted in opposite, acted on object in opposite direction. So that force acted in the opposite direction. So that's why we got work done. Work done is equals to minus 210 joules, or work done in negative. Okay. Yes, I will stop here. Tomorrow I will continue the class. So tomorrow I will ask questions because this chapter is completed. So hope maximum students will join live class tomorrow. Thank you.